In this session, we'll look at some other types of joins that are used with SQL. To get started, let's review a simple inner join. Recall that this is the default type of join that is used when you specify just the join keyword as shown here. In this example, we are joining the student ID and name columns from the members table with the advisor title and name from the advisors table. The data is shown in order by the student name. The on condition is in the advisor ID, which is the same column name in both tables. When you use an inner join, you get data in the result set when there is a match between the tables. So what we get is a list of all students that have an advisor. We see the student ID, student name, and advisor name. Now let's change the join from the default inner join to a left join. The only thing that is different on this slide compared with the previous slide is that I've added the keyword left, so I now have a left join. When you use a left join, you get all of the rows from the left table, in this case the members table, whether or not they have a corresponding row in the right table. In this example, the right table is the advisors table. So the end result is we see all of the students, whether or not they have an advisor. Now we have a completely different type of join. The join is specified as a right join. You can see the results starting at the first row of the result grid. We see that Dr. Drake has not been assigned as the advisor for any students. So the right join takes all of the data in the right table, which in this select is the advisors table. It lists all of the data in the advisors table, whether or not there is a match with data in the members table. Now this might look a bit odd since we're not used to looking at a result grid where the data in the left side is shown as null. You'll see on the next slide how we can flip things around in the select statement to make it look like you would expect. Look first at the result grid on this slide. The first column is the advisor name. You can see that it shows the advisors whether or not they have been assigned any students. Dr. Drake is the first advisor listed, and he does not have any students assigned to him. Now look at the statement, especially at the join type. You see that this is a left join. Several slides back, you saw a different left join. The difference is the order in which the tables were specified. In the previous left join, the from table was members and the left join table was advisors. On this slide, the from table is advisors and the left join table is members. Recall that with a left join, you'll get all of the rows in the left table, in this case, the advisors table. If there is matching data in the right table, the members table, you get that data. If there is no match, you get nulls. This slide shows the left join on the left side of the slide and the equivalent right join on the right side of the slide. If you look at the result grids, you can see that the data in the grids is the same, it is just in a different column order. On the left side, the advisor name appears first, so you always see data in the left column of the result grid. On the right side, the student ID and name appears first, so you see the null values appear first when you have the advisor who does not have any students assigned. Keep in mind, as far as SQL is concerned, these two result grids are the same. It really doesn't matter to SQL which order the columns in the result grid are displayed. Now, it may or may not make a difference to you which order the columns are displayed. If you will be creating an SQL statement for an end user, for example, to import data into an Excel workbook, they might find it easier to understand the data if it looks like the left side of this slide. The result grid on the left emphasizes the advisor names, not the student IDs and names. If you are writing an SQL statement that will only be used in an application, the application itself will pick out the column values that it needs from the result set in the order needed by the application. For example, if you will be displaying this data on a PHP web page, you can use the PHP code to put the data into the order you want it displayed on the web page. So based on what you're seeing here, you can get the same results for a right join by using a left join. Note that you do need to set the orders of the tables correctly. It is not just a matter of substituting the keyword left for right. To finish up our discussion of joins for now, we'll look at a very unusual type of join that has a few specialized uses. This type of join is called a cross join. Technically, it is considered to be the multiplication of all items in one set with all items in another set. This is referred to as a Cartesian product, named after René Descartes. In addition to thinking up mathematical theories, Descartes is probably most famous for his musing cogito ergo sum, or I think therefore I am. That statement causes endless hours of discussion in Intro to Philosophy courses. So if you are interested in pursuing that, you can look into those courses. So let's take a look at what a cross join is and what it produces. We're using the advisors and members table again. This time, the from table is advisors and it is cross-joined to the members table. Everything is put in order by the member name. What you get in the result set is a list of all of the advisors joined to all of the students. This slide shows two sets. There are many more in the actual result set. You can think of this as being a set of all the advisors joined with each individual student, looking at it from the left column to the right. Or you can think of this as being a set of each student with all of the advisors listed, looking at it from the right to the left. As is, this result set does not seem to be that useful. It's just everybody joined to everybody else.